Yes, Ma, you can start.
A very good evening to all respected dignities, faculty members, and participants. It gives me a pleasure to welcome you all to today's 7th session of ATAL FDP, aimed to enhance academics and research excellence through emerging technologies. The topic for today's session is AI and machine learning applications in electrical vehicles. This session highlights how artificial intelligence and machine learnings are enabling smart battery management, intelligent charging system, fault diagnosis, predictive maintenance, and energy optimization, thereby accelerating the growth of sustainable electric mobility. It is my great privilege and honor to introduce today's esteemed resource person, Dr. R. Senthil Kumar. Dr. R. Senthil Kumar is currently serving as an associate professor at Vellore Institute of Technology, Chennai, and brings with him over 12 years of experience, academic research, and industry oriented teaching experience. He has completed his bachelor's degree in electrical and electronics engineering and master's degree in power electronics and drives from Anna University, Chennai, and earns his PhD in the area of fault diagnosis and advanced control techniques for electrical drives. Dr. Senthil Kumar has a strong research expertise in artificial intelligence and machine learning applications in electrical vehicles, energy management in DC microgrids, EV charging infrastructure, fault diagnosis of electrical drives, and intelligent control system. He is actively guiding PhD research scholars in cutting edges areas such as IoT based EV charging stations and AI driven energy management system. He has published more than 60 research papers in reputed international journals and conferences and has received recognition for his contributions to research and innovations. His academic contribution also includes patents and publishing in the field of artificial intelligence for energy management. He serves as a receiver and editor for leading journals published by IEEE, Elsewhere, and IET. In recognition of his outstanding research contributions, he was honored with the Best Research Award the academic year of 2022 to 2023. With a strong blend of technical knowledge and practical research experience, today's session on AI and machine learning applications in electrical vehicles promise to be highly insightful and enriching for all the participants. On behalf of the organizing committee, I extend a warm and hearty welcome to our esteemed speaker, Dr. R. Senthil Kumar, and inviting him kindly to take over this session. Thank you.
Evening to all. So once again, I would like my sincere thanks to CSNA College of Engineering and Technology for conducting 6 days Saturday FDP program on AI and ML application in electric vehicles and renewable energy systems. My sincere thanks to HOD Dr. Chandrasekharan sir and coordinator Dr. Vimala ma'am and co-coordinator Uma Maheshwari and organizing members, committee members, Saravanan sir, then Pushpavana sir and Kalai Shelvi ma'am for excellent coordination for this program. So actually 2 days back, we have seen the machine learning parts and classification. We have used some real-time data sets about the PV panel set and the how we can train the system. We have explained with some algorithm. We have explained the concept with 4 or 5 different ML algorithms, and finally I have told how to check our answer will be correct or not. Okay, I think you will have any doubts about the classification. So in this today class, actually still in machine learning, we have one pending topic is there, that is a regression. So we'll complete the regression and we will see that the comparison between machine learning, deep learning, AI, because we have some confusion about that, which application will use ML, which application will be deep learning, and which application will be AI. So we have some maybe confusion will be there. Okay, so we will see slowly on that topic, and we will also see that deep learning, one of few algorithms. And normally we are facing that now. Suppose if we are having images, means how to upload the data, how we can find that prediction system. So that also today we will discuss. Okay, so normally if Excel data is available, you can easily train the system. So how picture is available, if any your data may be in picture images also. So we will take one real-time data set around 6,000 images and we will train to the system. Okay, so today classes we'll see these topics only, and we'll train the system with the EV data. So we'll continue with the help of the another topic is regression, okay, in the machine learning. Okay, so regression means we have discussed in the last class, I think. Classification, your answer may be yes or no, true or false, or multiple classes are presented. That will comes under the classification. So regression in the sense, suppose if you want to predict your output in terms of the values, in the sense, we need to go for a regression. Okay. So in that type of regressions, first one is linear regression. Okay, so linear regression categorized into two types. One is a simple linear regression, another one is a multiple linear regression. Okay, so what is the linear regression? Simple. Now we know the straight line if equation y equal to mx plus c. So that is a linear relation. So if suppose I have a data about x-axis, okay, suppose I have a data about 1 to 100. In 101, the 101, the data, what will be the prediction? So that is called the linear regression. It will be your prediction model would be in a linear scale. It will not be in different kind of input. That is called linear regression. Simple linear regressions now only your axis may be in the two-dimensional axis. So only x and y is one presented. Multiple linear regressions now it may occur in the other side of the axis also. That is called multiple linear regression. So here actually exact meaning is we are going to find a relationship between one independent variable and one dependent output variable. That is called simple linear regression. So multiple independent variables are presented. Okay. So where we are using that linear regression in our electrical side, in the sense, suppose you are going to forecast the power system prediction. Suppose you have a data about 1 year about power generation about your college or your transformer or your block. Okay. Suppose consider that I am working in one college. In our college, we have a different blocks are there. So consider a block number 1. We have separately maintained the day wise, in time wise. We have voltage value, current value, power, and what is the power factor. Okay, then feeder wise power. We are periodically monitoring, and we can note out that. Suppose I have 1 year of data in our particular college instance. I want to predict that what will be our exact what is the electricity bill will come for next year. I can be predicted based on the present load levels. Okay. So this is called a linear regression model. So this is a regression. Okay. So this is nothing but a forecasting. You have some vast amount of data will be there. You are going to forecast that based on that your previous models and train the system. So that is called linear regression. So it's nothing but y equal to mx c plus concept. Okay, for example, I am working on industry or organization. I am working 10 years. Okay, this is my salary growth rate, right? So, so each and every organization they have their norms. Okay, so based on that, year of experience increases, salary also increases. Okay, so that suppose I am working on institution 10 years. So what will be my salary in the 11th year? Based on the 10 years of data sets are presented, it may predicting our salary. Okay, so this is called a simple linear regression model. Okay, here just for example purpose, I give one example where one is weight, another one is a height. Okay, suppose in the sense I want to find that y equal to mx plus c formula. So that is then one is nothing but intercept, another one is nothing but an constant variables. Okay, so a0 and a1 we have to find with the help of that formulas y equal to a0 plus a8. So from that we'll get some answer. Okay, so here what is the meaning? We have different amount of data set is there, right? So in that I'm going to predict about a new data. I have 7 data are there. In that, suppose if I give a new data, how it can be able to find? So I need to create one equation. Okay, so what is the equation? It is a linear equation, right? So this equation we should be predict. Okay, that equation only it is represent 0.32 plus 0.221x. So this equation now it will not change. So if I give the any kind of x value, the y value will be predicted. Okay, so this is called as a linear regression model. So the final answer will be in a linear shape only. Okay. So this is called a multiple linear regression model. Multiple linear regression models are two independent variables are presented. So in every time I will not use only one variable. Okay, multiple variable also we may use. Okay, mostly multiple variables we can predict. Okay, so for example, number of year of experiences plus number of targeted which can attain our salary may be increases. So number of input also may be increases. Okay, so this is called as a multiple linear regression model. The remaining concept are same, but additional constants we have to find. So here previously one constant A0 and A1 we have found. Here multiple constant you have to find. Okay, that is called multiple linear regression model. Another one is a logistic regression. Actually, the name itself is a logistic regression, but we can use this logistic regression in the classification applications. Okay, because here the value of a ranges between the look like a S shape. S shape means your values are changes between 0 to 1. Okay, so we can use for classification purpose. Normally, we can prefer the logistic regression also one of the comparison. Okay, so the value which is predicted instead of 0 or 1, 0 to 1 exact probability value it can be predicted. Okay, so normally this curve may be used in the all kind of neural networks model. That is an sigmoidal function, 1 divided by 1 plus e power minus x sigmoidal model. In that activation functions we are using the all neural network model. Okay, so what is activation function? We have to introduce a non-linearity of the entire any system in the sense that is called activation function. So we can use that in that machine learning also. So normally this curve is called as S curve shape. Okay, it will be used in the classification purpose, not only that regression purpose. For example, one of the students have studied different data sets are there. Okay, suppose in the data sets my output will be 0 or 1 only. Here the values are not presented, right? Only output is pass or fail. Okay, suppose if I give that 32 hours in the sets, how students will be get a pass or fail. Okay, so here even it is a regression model, but output is a classifier. Okay, so mostly we can use this logistic regression as a classification model. Okay, so we have to use the sigmoidal function, and we can identify what is that exact chances to get a pass mark, or what is the probabilities where students get a pass mark. So that kind of data supply, that kind of data, based on the data, we can apply the logistic regression also. Okay. Then last class we discussed, right? Classification, some of the matrices are there for checking your answer. I can use that different regression also. Actually, previous our sessions we discussed about support vector machine, random forest algorithm, decision tree algorithm. So these all three algorithms we can also use in the regression also. So today I didn't include that algorithm because we have already seen in the previous lectures. So regression model in the sense also we can check our answer. So that is called matrices. Okay, title I have wrongly mentioned classification, but it's a regression algorithm. It is not a classification; it is a regression. So what is the matrices are there? So before that we have to calculate the error. Okay, here not accuracy. Here error is error. We will calculate the error. Okay, this is machine learning predicted model. This straight line which is represents machine learning prediction model. This dotted line represents after machine learning trained model. Okay, we have given training, right? 80% training, 20% testing. After training about a data, it will predict the model. Okay, so now the difference between this actual model and this predicted model, this is called prediction. Okay, this is called actual. So the average distance between the average of this prediction model minus actual model minus prediction model, that is called error. Okay, but we have more number of training model sets are there, so we have to calculate this average. So summation we have to introduce. Okay, so here there are four types of error is presented in this your algorithm. One is MAE, MAE mean absolute error. It's called mean absolute error. So we can find that error value into actual data minus predicted data divided by total number of variables, total number of n values. Okay, suppose your data set will be 100 in the sense you have to use all. You can take an average about error of all the 100 data. So that is called n. N equal number of samples. MSE mean square error value. It is called the mean square error value. So it's equal to the same value, but here yi minus y bar whole square. Okay. So it is not an, actually we should not get a negative value initially. So we are using this model symbol. Okay. Magnitude symbol. So yi equal to y bar now. Suppose if we are going to calculate the differences. Okay. Suppose 2 minus 5 now, answer will be in 3 only we have to write. Okay. So we are using this bracket, but MSC means normal bracket only we are used because it's a square. Okay. So that is MSC. Third one is root mean square value. RMSC, root mean square value. Square of this MSC is called as root mean square value. And finally, R square value. R square value is equal to, we can take a mean value also for consideration. 1 minus summation of yi minus predicted model. Y cap is nothing but a predicted model divided by yi minus y bar. Y bar is nothing but a mean value. Mean value. Take a entire actual y mean value, then find the solution. So here, for example, you are using machine learning classification of what we have previously discussed. Your accuracy is major part here. Your accuracy will be in more than 80% or 90% should be there. It should not be a very less percentage. Similarly, here also your error value should be try to get a minimum value. That is your ultimate objective. Okay. So based on that, you have to change the parameter. Okay. Suppose now if I am running one data set, okay, I will use some different algorithms also. But every time it will be changes. Okay. Suppose I am taking random for 0 now. Sorry, random, not a random, but a random state. If I take a random state 0 now, it will take first 80 value. Suppose take a random state 1 now, it will take a different value. So your answer will be changes every time. But your role is what are the parameter you are changing in the trial and error method to get a accuracy, to get a very minimum error value. Okay, that is our role. So every time we can take them. Suppose you are not getting that exact answer, like suppose I got a error value 5 now. The problem is you are training your data set. You are using your data set with very minimum only. Okay, so if you have a very minimum amount of data, underfitting problem will occur. Underfitting problem, here it is not maintaining a good accuracy, or not maintaining a more kind of errors. At the same time, if you are uploading more amount of data sets and a large amount of data sets, now we will also meet the overfitting issues. Okay, so that issues we'll discuss in the upcoming slide. So that also we have to consider. So you may think about that why they are using different algorithms. Every time it will be changes. Yes, still possible to changes that. Based on that trial and method, you have to change that. What are the training parameters are there? Actually, in deep learning, we have separate option is there. What is separate? Hyperparameter tuning is there in deep learning. But machine learning, we didn't have any options. The changeable parameters are very less in the machine learning model. So what are the possibilities ways are there to have a minimum kind of errors? We have to take it. The main one is data sets. Well, then what are the training parameters? Suppose if we give an, for example, I'm telling 80% training, 20% testing, I am suggesting. If you are using 50 to 60% training, 20% testing also, we will get a different mean absolute value, mean square value. It depends. Okay. So we cannot give that. So only I am telling about that this algorithm is better one. This we cannot tell that. It will be changes. There are a lot of parameters are there backgroundly working. Okay. So these are the 4 important parameters: mean absolute error, mean square error, RMSE, and R square error. Okay. Just one small explanation. I just explained the code, then I'll go to that. I'll directly explain the code. Suppose I want to predict the salary in the sense that salary, my employee salary means first I have to import the libraries. Okay, what are the import the libraries are necessary? So NP na panda, numerical polynomial I will use. Then my plot will be MATLAB plot will be 2-dimensional axis, because I want to see, if we want to see the results now, plot now we can need it. For data handling now we can use the pandas. Then matrices I have to import. Okay, that is called mean underscore absolute underscore percentage underscore error. Suppose if you forget to mention this also, error will come. You just click the explanation error, automatically the code will be generated backgroundly. Okay, yesterday we have discussed, right? So it's based on AI tool only in Google Colab. It's an AI tool only. So simple net connection is enough. If you forget to write this sentence also, not an issue. It will automatically provide a code or sentences. Okay. Import math operation also. So first I have to import the data sets, then x value, y value, print the x and y value, then splitting about the data sets, Okay, directly I am going to splitting about data sets. It's not necessary to go for an encoding process and missing values. Okay, suppose you have all amount of data sets in the sense, no need to go for a missing term. Suppose in a data set, only numbers are there, means you can omit the encoding process. Okay, so I pick the data set, training and testing. I just use one model. First, you can import the linear regression. You should not change the linear regression. You should directly use linear regression model. Then fit the model, predicting that if you want, you can give any number of value, answer will come. Okay. So based on that, you can plot your waveform. Okay. So first, I will explain one error, how we can find the errors. Okay. Then I will explain with one data set with a different kind of regression of that. So this is the table just upload. I'm going to upload. Okay, actually this is a data real-time data set about one TNEB station. Okay, so we have collected 1 month data. Actually, they in Tamil Nadu Electricity Board, they are what is the actual power and what is that the power they are distributing into each feeder. Okay, actually we have collected real-time data set. Just for your error purpose, that's I'm showing this code to you. So this one data set is presented month-wise, day, hour, SS substation value, actual value. This row 1, row 2 is nothing but a different feeder. Actually, each TNEP station, it will be connected to different feeders. Okay, so around 20, 30 feeders are there. Okay, so for example, I'm telling. So here one amount of data set will be there. So, but it is SS nothing but actual data. The F is nothing but predicted data. We have used some algorithm, right? For example, linear regression, so multiple regression. We have used some algorithm and we are predicting answer. Okay. So now here actually we have a data set about 745 data sets are there. Okay, because monthly wise only 1 month we have taken, so data sets are very less. So here just I upload the data first. Okay. First, you just import the libraries. Okay, so pandas, numpy, matplotlib. Seaborn is not necessary for confusion matrix. Now you go for Seaborn, otherwise not necessary. Remaining normal mathematics only. For mean absolute error, you have to call mean import mean percentage absolute error. Just upload the data. Okay, so file name is table 1. Okay. So also it is a consecutive process. Suppose without running the without the uploading running about table 1 data, suppose if I run third the parameter, means the error will come, because you have to do the process in a sequential way. So that is a major part. So first we need to upload the data set. Okay. So if any non-filling item in the sense, take a mean value. That concept we have already given, because sometimes we may also miss the value. it's DF. D is nothing but I am giving one different value. You can give any values to here. DF dot head. That means what are the table values are there, it will display. That is called TF dot head. So in a table, what are the values are there, it will be displayed. Okay. So we need I am going to find the error. Okay. So I need a two value. One is a predicted value, another one is an actual value. So first I have to select first I want to find that what is predicted value. So I give another name DF1. Okay, so DF1 is nothing but predicted. I'm assuming DF1, you can give any value. It's nothing but already we are giving that the whole table name is DF. Okay, so what is the file name is available? You should not change the file name. Here, capital SS is present there. So you have to give the same capital SS. Okay, otherwise error will come. So this is called actual value. Okay, this is nothing but actual value. That value will be displayed. Then DF2 is equal to DF row 2 I am taking. You can take any row value. I have a different row values are there. I take randomly row 4. Row 4 it may be used when some algorithm you have. So that is taken as there is an actual value. Row 4 is nothing but the actual value. So predicted value, now you have two data. So one is predicted value, another one is having the actual value. Okay. Now you just find the error. Okay, now error is coming. Why error is present in the sense before you calculating mean absolute error, once again you have to import the values because we know that mean absolute error for DF1 and DF2. So once again you have to call for mean absolute error in this code also, in this box individual code also. Okay, so even if I forget, just to give you explain error, the suggestion will come. Okay, so it will tell the error value. What is the error you are mentioning it that. After check it, that means you can give accept. Okay, then you can verify. So automatically now it will come, right? So from sk.learn matrix import mean underscore absolute underscore error. So then you can run the error value. Okay, so error value is 0.602. Okay, it is taken as an average value. Previously we have seen the formula, right? It is automatically calculated. Similarly here also you can MSC is equal to mean square error equal to sk learn that matrix as mean underscore squared underscore error df1 comma df2. So one is predicted, other one is actual. Just run it, you'll get a mean square error value. And then RMSE. Math.square.msc. Square root of MSC is called RMSE. So that value is 0.76. Last one is R square error. So that we can calculate with the help of the correlation matrix. Okay. So 0 to 1 actually we have to fix and we can run. The answer will be coming float point. Okay, 0.93. So that is an R square error. Okay, so less than almost 0.921. It's a very good R square error. Okay, you are suppose if you are getting 0.6 or 0.7 even itself, it looks like a 70% accuracy. So if you are getting means what is the problem? Data set is only the problem. Suppose if you are not getting that value or prediction, you are going to predict that model with the help of some basic algorithm also. So that's what only I have told that there are a lot of things are there for checking. So every time you will not get the same answer. Okay. So every time, suppose if you are selecting different testing training and testing parameter in the sense, now I'll get a different task error. It will be changed based on that tuning parameters. Okay, so this is a very important one in the regression model. Okay, so we have to calculate the error. That is our output. Similarly, classification, we have to calculate the accuracy and R square error and remaining model. Okay. Now I'll just show that one regression model. Okay, so this is one sample data set I have taken from Flickshare. This is that charging EV charging data set. Okay, so one is connection time, another one is a charging duration, how much power is delivered per day. Okay, because it is not an uniformity. Okay, some of the day electrical vehicles may come very high, or some of the days we can get a very minimum amount of charging vehicles. Okay, it changes, depends on that. Okay. So for here, if I increase the data set about 1 lakh data sets, in the sense the running time of the code will be increasing. So only I am what other thing I am explaining to you. I am explaining with the minimum amount of data set. Okay. So here actually data set is around the 7,000, 4,000 data sets are there. Okay, so just to understand the data set first. Okay, so one is connection time. So 15 time connecting time, charging duration, then how much power we deliver in the day one. Okay, now I have around 69 days charging data sets are there. Okay, so now I am going to predict that if we have a different kind of connection time or charging duration, means how much kilowatt is delivered. Okay, so here X value will be connection time, charging duration, single or double. Okay, suppose connect time also you can take an X value, or charging duration also you can take X value, and combinedly also it can be take. It's not an issue. But output is here is key delivered. That is an output. So target value. Okay. So now I will use some different algorithm. First, I check with the basic algorithm, linear regression, for this data set. First, upload the header file. So I gave the number is sample. So file name also sample, dataset equal to pd.progress excel sample dataset. So X dataset I am considering only connection time interval. Okay, connection time interval dot values. Y value is kilowatt delivered, how much power is delivered. Okay. Meanwhile, you can check that your X value and Y value if you have any doubts. That line itself. Okay. It show in the array format. Suppose if you type print text now, automatically the value alone will be displayed. Okay. So I have all the values. Okay. So I don't want to go encoding process, and all the values are there. I don't want to go encoding process, and I don't want to go the missing values. Okay. So just I close this window. Okay, here from SK model dot import train and testing. So splitting about the data sets are record. So X train, X test, Y train, Y test model equal to train underscore test underscore split about the data, X value. Just a minute. Sorry for the interruption. Okay. So X training and testing about a data set, you have to split. So one is X value, another one is a Y value. Test size 1/3. 1/3 na 0.37. Okay, 0.33. So 0.33 na only you are giving weightages for 60%, 63% about a data only for a training about a system. So I just change it. Okay, I give 0.2. So 0.2 na 80% data I give for a training. Random set 0 na first value, first 80 value it will be take. Then random set 1 na it will be randomly taken. Now I put random set 0. Normally you can prefer random set 0. Why? In the sense, when you are facing the problem, in the sense, suppose final output we need in terms of the error value. It is personally I am facing that issue. Random set, if I give one, it will be randomly taking, and I have predicted the model, right? But it is how it will randomly taking, we don't know. Okay, so I need a error value now. I need a error value in the sense I need a actual value and predicted value. So actual value I am having in the sequential way. Okay, actual value I am having in sequential way, but predicted model is not in a sequential way. Okay, so that time if you are calculating same data set, in the sense, the problem will come. Even though we are taking the average value, but you think about the classification. So classification, in the sense, the true positive and true negative, it will be calculating only for actual value and predicted value. Okay. So normally I am avoiding random state, but random state 1 also it will give a more accuracy. Then import linear regression model, distributed hybrid regression model, test type linear regression, X train and Y train data set. Okay. So 0.2, training data is 0.2. So totally the data set around 700 only. Okay. So now once we develop the model, once you're running, a small window will come. So you are running in a correct way. I'm going to predict a y predict equal to regressor dot predict underscore test. Okay. So now it is the suppose here it will be predicted. Suppose if you type y underscore predict, you run in the sense entire value will come in terms of the array format. Okay, yesterday previous class we discussed, right? Suppose you have if you want the value in the sense you can directly you can convert it into value into Excel format. Okay, then you can find the error value. That is one option in the same time. If you want exact value also, okay. For example, instead of one test value, I can pick any one value randomly. For example, 13.2 is a connection time, right? If I run in the sense, error will come. Why error will come? This syntax is wrong. Okay, actually double bracket will come. Okay, so go through that all the point. Okay, explain the error. We have to give that square bracket, double time square bracket. It is not necessary to download all the values. You can give any value randomly. Now it automatically error will be changes. Okay, so np dot, because all the answer in array format, right? So np is a numerical term. So np dot array format double colon double bracket double square bracket 13.22 randomly again. Now you run in the sense this 13.22 answer will come if it print now. Okay. So and first also I given y prediction. Second also I given y prediction. So that also miscommunication will be present. So automatically it will be considered y prediction underscore single. Okay. Automatically it will be changed. Suppose I want to predict 13.22 now, that answer also will be displayed. So 13.22 now, the kilowatt delivered will be 9.35. So this is the machine learning is predicted. Okay. So there are a lot of options are there for fine tuning every parameters here. Okay. Then scatter plot. Okay, so now I have trained machine learning model is predicted. Now already it was predicted the data 20% data for testing. So that is your y-axis. Okay, that is your y-axis. Then corresponding that is the x-axis. Sorry, corresponding y-test answer will be marked in the red color. Okay, this red color is nothing but so already we have conducted a training model is predicted. Based on the prediction model, suppose if I give a x value, corresponding y value will be displayed in the diagram. Okay, so this red color represents the training graph. Okay, then basic things are tested, right, while plotting the graph. So scatter plot okay, means scatter plot for testing and x test and y test parameter. Plot with the deals on training model, regression that predict extra model, that is the blue color. Okay, that also we are mentioning. Color of blue. So color blue, which is represents the prediction model. This is a machine learning predicted model. And this green color represents the actual model. Okay. So that is we are mentioning in the red color also. You can give any colors and check it. Then title you can give X label and Y label. If that we can show. And also we can download the images. Suppose I cannot. Suppose if you cut these images means if we cut these images in the sense clarity will be very less. So we have to use the same code. So you have to use the code for downloading the images also is possible. That I will show in the next. Okay. So this is a linear regression model. Similarly, I will run another algorithm for same data set. Only I have changed in this only one the algorithm decided alone. Okay. So now I have shown that about linear regression. Now I will show that support vector machine, SVR, support vector regression. Okay. Yesterday we have discussed support vector regression is to find that extreme data sets point about yes or no. Okay. Same way it will be find extreme data points. Now I upload the same data. Just see that where I have changed the code. First import the header file. It is a library. Upload the data set. I upload the data set sample.xlx and the system. Actually, Xdata connection time interval only, not a charging duration. Then standardization I am introducing here. You can introduce standardization or without standardization. Okay. So, but you have to fit the model and reshape also. So here it is not necessary to find the standardization here because there is no large amount of variations are there. Even though less value also you can be used, it's not an issue. Okay, all the values will be converted into 0 to 1 or -3 to +3. So within the range only the value will be present. So if you want, you can use with standardization, without standardization. But large amount of variations are presented in your data set in the sense compulsory you have to use the standardization for feature scaling. Then I import the training and testing data sets. Previously, I used that 0.2. So now only again I use the 0.2 here. So only 80% data it will use for training. Then I use that only this step is changes when compared to the previous step. When compared to the previous algorithm, only this step is alone changes. Okay. First, I have to import the SVR support vector regression. Suppose classifier now you just take the previous classes. I use SVC. SVC na support vector classifier it will take. SVR na support vector regression it will be take. Okay. So kernel function you have to select. Kernel means it is used in the tuning parameter. RBF na RBF radial basis function. So that is one of the mathematical model. Then you can train. There are 7 or 8 kernel functions are there. You can use any one. Then take a mean value. This is a combined features value. They're additionally added for output waveform for reshaping the parameter. So I am using the standardization, normal standardization. So only I am using the additional step. The remaining steps are similar to the previous one. Okay, now previously linear regression. Now it is not a support vector regression. So this is a predicted model. The corresponding the red color indicates that actual model based on your training data sets. Okay. So here I want to download that images. So I have additionally added one code. Okay, so first I have to fix the sizes 8-inch, 6-inch, and the color I have to fix same code only, but additionally I have added fig comma ax. Okay, figure and axis I have added for a better clarity. Okay, finally I have to type the entire layout and give a name dot save figure in terms of the PDF .pdf format. You can give any name. Okay, you can give any name. And show the values. Just run it. Go to file symbol. If you refresh it, that PDF will come. Okay. So after that, you can download it and skip the file. Okay. So there is one option is there. So another option is also there. You can also change that the waveform in here. Sorry, here you just see that I can't edit anything, right? So the results are displayed. Just I will save the file. Okay. But in MATLAB, in figure plot window, we have multiple options are there to edit the particular waveforms. Okay, in figure plot window. So even the same code, same kind of these values, we can also convert it with the help of this chat GPT or some other platforms are there. Convert all code in all this training platform value in terms of the Excel. Actually, Excel value we can be downloaded. In the code also we have to transfer. Then you can use that, upload that Excel value in the MATLAB. Okay, upload the Excel value. Here we know that how to download the Excel value, right? You can upload the Excel value in the MATLAB, and if you have two values, you can easily plot in the MATLAB figure.file in the MATLAB any versions. Okay. So here actually I can't change anything. After downloading the result, just a snippet and we can be paste it there. MATLAB we have so many options. And suppose if you want to indicate this blue color will be someone. Okay, this single waveform is okay. Suppose I want to display one single waveform with a multiple algorithm in the sense we have to go for a MATLAB. That is the only best option. So this is an one algorithm I have tried. Similarly, same only the changes to the code is algorithm selection. Okay, so today just I tried decision tree and algorithm and random forest regression also. So random regression, same data sets. Additionally, we have download the values also. Okay, that is I mentioned here. Okay, only change in this code. Okay, import decision tree regressor, random set I put 0, that regression model. Okay, then it will be select the regressor model in any kind of things. So remaining all are same. I didn't change anything. Actually, here I using the standardization normalization only. Additionally, some features parameters are there. There is not required. Then plot a waveform. Suppose if you want to show the results, okay, this is then blue color indicates the prediction model. Red color indicates the actual model. The training data set. Suppose I want to download the results. You pick some region. Okay, same things. Then run it. The corresponding file name will be displayed. It can be downloaded. You can also save the data in the Excel format and finding the error value, what we have already seen. Okay, so that's all about this. This is called regression. So additionally, I have random forest regressions also. That just a one step will be changes, remaining all are same. Because every algorithms only most of that data pre-processing. Here I have done data pre-processing as well as the algorithm selection. Okay. So if you have proper data sets, you have a valid requirement of valid requirement of data, valid amount of data pre-processing means answer will come. So random forest regressor. Random forest regressor means we have to select the number of trees. Like instead of we are training the single tree, we can also search the multiple amount of trees. So we have to select the number of estimators we have to select. The remaining all are same. First I import header file, libraries, upload the file. Yeah, only this step is changes. I just put the number of estimator 100. That's nothing but number of trees. So it will take randomly taken 100 trees, take average values and find the exact prediction. Okay, so this is a random forest regressor. Remaining are same. For data sets. Here I have already explained. Okay, how we suppose same Y grid prediction array format, the answer will be displayed. You can also plot the graph. If you want PDF also, you can put a PDF. Okay, so here I want to save the file in Excel format that previously I have discussed, right? So I just type that the column value, predicted column value to Excel format. Now I go to here. If I refresh in the sense, the prediction Excel format will come. Now if you want, you can download it. Okay. I've already explained how to download PDF. This is also very important. Okay, now it is predicted model, right? Now you have predicted model. Okay, so here it is nothing around how much values are there. So in my sample data sets, 2398 models. Okay. So this data set I have uploaded. So I have 4464 models. Okay. Still, for this coding, I didn't change that 1 by 3 instead of 0.2. So 1 by 3%, 67% of the model is training. Okay. Now, after I download the results, that 63% of the training model actual value will be displayed. Okay, this is the actual value. Okay, for random forest regression, actual value. You already have a predicted value. Okay, you already have a predicted value from the actual data sets. What is that? This is the actual data. You already have a predicted charge value is there. This is called predicted. This is called actual value. Now, based on the regression, you have predicted values. Now you copy the two files. Okay, this is called, it's nothing but an actual model, and this is called a predicted model. Okay, but predicted model training and testing database 80%, but random states 33%, 67%, but random state is I have put 0. Okay, so all the values are linearly presented. Okay, so you can take that actual value 67% and the predicted value 67% values are there. Now you can find the error value, get a mean value, R square error value, mean square error value, MAE, and make a comparison. Okay, so this is the way we have to conclude the algorithms, regression algorithms. Okay, so this is the way. Suppose you have a data sets. Okay, first work is data pre-processing. After pre-processing, you select the algorithms, tuning the parameter. Testing time, you can take that. But output is I have clearly mentioned, right? Accuracy should be maintained. Then you can save the file in terms of the SL. You can save the file in terms of the PDF, or if you want, you can take a code and convert into that Excel format, Excel into that MATLAB figure that window also. You can be edited. Okay. So that's all mainly about machine learning. So remaining you'll see. So this is kind explanation I have already provided. I'll go for next topic. Unsupervised learning, just I'll tell only one algorithm. So mostly we have gone for a based on the problem statement, supervised learning or reinforcement learning. Last option only unsupervised learning. Suppose you have a more amount of data sets are there, I want to predict the model in the sense. So instead of predicting the model, I want to classify from the overall data sets. Okay, so we are telling the name is called clusters, not a classifier. Classifier, we know 100% that cluster will be small groups. That is the meaning is a small group. So we have to change that your entire data into the different groups. So that is the role of the unsupervised learning, because it have a unlabeled data sets. Okay. So it have three important vertices. One is a clustering, another one is association, another thing is that is called dimension reduction. It's not mentioned here. Another one is called dimension reduction. So dimension reduction is, suppose we have to convert the dimension 3 to 1 or 2 to 1. Okay. So more number of data are there. We have to cluster under one category. That is the unsupervised learning. Here major thing is clustering and association and cluster dimension reduction. Okay. So just understand the different classification and clustering. Okay. The classification means individually we will divide it, dog, only cat. Okay. So cluster means we can go under one category. So that is a cluster. Okay. So at least if you want to cluster the data set, it can be easy to apply the next kind of algorithms. Okay. So one of the algorithm is K means clustering algorithm. Sometimes this algorithm, some of the problem statement we are using in the sub classification also we are using the algorithm. So I will run only one basic code about clustering algorithm, then we go back to the deep learning. Okay. How we can be run the code for us unsupervised learning? Just I tell that example alone. One of the algorithm is K-means cluster algorithm. It is nothing but a centroid based algorithm. So suppose I have a different data sets are there, it will comes under the one particular cluster. Okay, one 5 groups. Suppose um, I have a class. In my class students, I can be categorized into 5 different groups. I may categorize 10 groups also. Okay, but I feel that 5 is being more efficient. Okay, so here in that algorithm to select that 5 or 10, backgroundly one calculation is there. Okay, that's called elbow method.
எல்லாரும் நல்லா இருக்காங்க. அவங்களும் வர மாதிரி தான் இருந்துச்சு. வேற இருந்துட்டாங்க. அது ஒரு 5 நாள் ஆகுது, அதனால அவங்க வரல. அதனால வரல அவங்க. நான் கேன்சல் ஆகி அப்புறம் வந்து.
Suppose we have a n number of data set is presented in the sense, we can use the algorithms in a group. Okay, so they are using the normal distance calculation method. So what is the
அந்த மாதிரி மதுரைக்குள்ளே எதுவுமே வந்த மாதிரி தெரியலையே. ஈஷா வரது இல்ல. சரி.
Sir, can you mute the participant?
Okay.
Papa, could you please mute the
வந்தாங்க. சரி, அதனால கூட்டு வந்துட்டீங்க.
Thank you.
Yes, sir, please.
Okay, suppose you have a volume amount of data set is there. I want to cluster in a particular group. That time you can use that K-means clustering algorithm. But it is a work based on the centroid based algorithm. Centroid based means we are calculating formula, right? D is equal to square root of x2 minus x1 whole square plus y2 minus x1 whole square. So that algorithm it will be working. So based on your data sets, it can be categorized into small groups. So this is the background calculation is working while using this K-means clustering algorithm. It will find the distances between each data set points and it will categorize under cluster. Suppose in my problem statement, I need a 5 cluster based on my problem statement. This will calculate the distances. Okay, it will take randomly as the
Sadil sir. Sir, can you unmute yourself, sir?
Okay, sir. Okay, here we can use that number of clusters of algorithms. We will find that cluster based on the distance calculation. Okay, so we know the distance formula D is equal to square root of x2 minus x1 whole square minus y2 plus y2 minus y1 whole square. Based on these calculations, it will be categorized into number of clusters. Even to finding the number of clusters also, we have used one method called WCSS method. That also it can be decided while doing the program. So another clustering is the hierarchical clustering. So you're based on your data set, it will be find the model look like a hierarchy manner. So in that hierarchy also, under the hierarchy also, there are plenty of models are there, like average hierarchical clustering, minimum hierarchical clustering. Okay, so then centroid based hierarchical clustering. There are different methodology also, and we can be compared. Okay, so it will be calculating the distance, normal mathematical calculation, finding the distances, and fine tuning that your parameters values. Another method is called principal compound analysis. Okay, these are algorithms. So normally these principal compound analysis is mainly used for the dimension detection. Okay, so suppose three-dimensional data, four-dimensional data having in the data sets, if you want to can convert it into that single-dimension data we use for a principal component analysis. Actually, in MATLAB we have the option is there. You have a data set, so you can in MATLAB machine learning tool is there and deep learning tool also there. So in that time you can upload the data in the sense before selecting the algorithm, we have option is that to select the principal component. Okay, so mainly it is used for getting the dimension reduction. It will give the under the matrix calculation. Okay, we will find the orthogonal matrix, we will find the eigenmatrix, when the covariation matrix. These are all of the steps are there. It will reduce the dimension of your given problem statement and provide a suitable solution. Okay, these are various steps are there for using this algorithm. This all are comes under the unsupervised learning network. These are calculations are there. I don't explain that. You can refer any kind of material. So the role here is three-dimensional data is there. It can be converted into the single-dimension data. It's a two-dimensional data, right? So it will convert it into the single-dimension data. So dimension reduction in the sense that also we can be easily label the data set. So we can use the supervised learning easy method. Okay. So just I show that one code. Unlabeled data sets. Actually, I didn't get any EV data sets, so just a basic data sets. With the help of the basic data sets, just I explain here. I have one data set. Here, number of clusters and purchasing data are very high. So I want to classify under one category. Okay, so in that cases, how we can use this algorithm. So first here, import libraries. Okay, it is not a labeled data set, right? So no need to go for a remaining thing. Just you upload the data correctly. Okay, X data set and Y data sets. That's all. No need to go normalization, standardization. That is not necessary. Tweeting about the training and data sets not required unsupervised algorithm. Okay. First, we need to find how many clusters you are going to split based on your problem statement. Okay. So that is the major key here. We cannot tell that this is the 5, this is 6 or 7. That separate calculations will be there. Okay. That is called elbow method. With the help of the elbow method, we can calculate the how much number of clusters we can be used. Okay. So we can fix the ranges from 1 to 10. Normally, more than 10 clusters will not use. We can normally reduce the ranges or reduce the complexity. 1 to 11 we are fixing. Okay, so then we can use the k-means algorithm. Random state 42 times it will be randomly it will be take. It's not necessary to give a 42. You can give any number or 1 or 2 also. Then fit the model. Okay, then you give the title and show that one graph will come, right? Okay, so this is the graph, elbow method graph. So in that graph, yes, the x-axis represents the number of cluster. Okay, in this waveform, that corner point, elbow point. Okay, how our elbow is presented in our hand. Same way here, this point, this point is called as elbow point. So number of cluster will be 5. So with the help of that only, I can able to find how many number of clusters required in my problem statement. Okay. So after that only here I mentioned number of cluster equal to 5. Okay, I need to run k-means algorithm, number of cluster equal to 5. Okay, then k-mean plus plus, then predict the model. Okay, that's all. Now it can be visualize the result. Okay, so I give different like 5 colors, red, blue, green, because 5 clusters only. I give different 5 colors. Okay, that I give a name as cluster 1, 2, 3, 4, 5. Okay, here centroid is detected because based on the centroid only, distance calculations only, it will be categorized your data set from the data sets. Okay, so that centroid color I give yellow color. Okay, that I give a name is centroid. Then x-axis, y-axis, and the title. If I run in the sense, we have one waveform is there. Okay, here this plot represents clusters. So yellow color represents 5 clusters, but the data are very largely presented because I change the random state instead of 40 and the trend is 1. If that is I am telling here, each and every time we have to fine tune the parameter. Every time we will get a different answer. Which one is the optimized one? Up to that you have to fine tune your problems. Okay. Actually, if I change that random set 43, 42, that's an optimized model. If I, in the sense, now the data set will be nearby, it will be located. Okay. And also it is not necessary to mention this color. You can give any colors of the particular problem statement, and you can download the result as we previously discussed. Okay. So this is the way you can run the unsupervised learning algorithms. No need to worry about that data pre-processing here. Okay. Then next one is the reinforcement learning. So it's a very big topic. It is an work based on that feedback received in the particular environment. Okay, so I just explain basic thing only, how we can be attain the values. Okay, so it is interacting with the environment and they will change the decision. Here, reinforcement learning, there is no label datasets are required. Supervised label datasets are required. Here, there is no label datasets required. It is learned based on that algorithm, the surrounding of the environment. Okay, so here the algorithms are very less in the reinforcement learning. Okay, so we'll go deep learning. Then once again we'll see that. Okay, now almost machine learning topics are over. I have run the different EV datasets and PV panel datasets also. Okay, now I'll explain basics about the deep learning. Then I will train one big images, how if images are presented, how deep learning is working. Okay, because running the Excel dataset is very easy, but the image datasets in the sense somewhat very cautiously have to use that. Okay, then after that I have one if time permits I will run that code with the different algorithms in the deep learning also. So we have one data sets about the electrical system, the electrical power system data sets. If possible I can run that also. Okay, so deep learning, first you understand the difference between machine learning and deep learning and which problem I will use the deep learning. Okay, that is we mostly will get a confusion, so that we'll discuss now. Okay, so deep learning is a part of machine learning. Okay, so what is machine learning role? Machine learning, we are uploading the data. It will search that first it can be extract the feature extraction. Okay, which after feature extraction we can use that whether classification or regression. For example, this is the input. Okay, so in that input I have uploaded the different of image data sets. After training the model, consider this is a testing data set. Okay, if I upload this image now, based on the feature extraction, it will be classified it's a car or it's not a car. It's a classification. Okay, classification. Suppose we have different vehicles also, we can be present as a input. Okay, so machine learning will give classification answer or regression answer, not beyond that. Okay, but deep learning means deep learning basics is called as basic structure knowledge is required about artificial neural network. So whenever you have a complex amount of data sets or increases, this deep learning works better than the machine learning. It will predict the features in a minute level. That is a deep learning. The name itself understand that identify your answer in a deep level. For example, it will the same question. If you ask in the deep learning, it will predict the car color, which model is there. Okay, then which make, which model. Okay, everything it will be fine. Okay, it will be everything. It will be estimate or implement. Okay, so that is the difference between applying machine learning and deep learning. Okay, Then remaining data science big data is a combination about small deep learning concept is present. Okay. Actually, in deep learning, presently we use that AlphaFold model. Okay, so actually this concept is started from 1958. So we know that, right? Basic neural network model, biological neural network, artificial neural networks, then backpropagation network, feed-forward network, everything we have studied 10 years back. So that is then basic level of neural network. Advanced level of neural networks only deep learning. Okay. So after 2010, there are different models are developed. So one is an ImageNet. Okay. Now AlexNet is there. 2012. So now previous 2018 itself, we are using MobileNet, GoogleNet, all are the deep learning models. Then GAN, then generative AI. Okay, so present thing is AlphaFold. That meaning is AlphaFold based deep learning methodology. These are the names they are being used in that neural network side based on the developing. Okay, presently we have used the AlphaFold methodologies. So neural network models, we may cross this basic model perceptor onto radial basis function, deep learning, recurrent neural network. It is an algorithm, deep learning algorithms. Recurrent neural network and the LSTM, long short-term memory, gated recurrent unit. Okay, so presently we are focusing these algorithms on like RNN, LSTM, by LSTM, gated recurrent unit. Okay, so here in deep learning, we can go beyond the options. Okay, there are advantages about the deep learning is we can go beyond the option. For example, if you take a LSTM now, in LSTM subcategories are there. If you take a CNN, like a convolution neural network, in convolution neural network, under more than 10 or 12 models are there. But here we cannot categorize more in the machine learning platform. For example, random forest now, we can use only XGBoost algorithm. Even linear regression, logistic regression, very few regressions are there. Apart from that, we cannot go. Okay. But in deep learning, we have options for selecting that algorithm in minute level. Okay. So these are the various neural networks algorithms are developed from perceptron to and Markov chain model, Hochfield network, Boltzmann machine, convolution neural network, deep convolution neural networks, generative adversarial networks, extreme ELM machine learning modeling. Okay, hybrid also we can be used. So these are the things are there in deep learning. Okay. So where we can use AI. So AI means suppose you are entering one product or you are entering one problem in the suppose inquiry chatbot. Chatbot is there. Suppose if I ask any question, it automatically provides some answer, right? So that is called as AI. Okay, so or if I'm using fuzzy logic concept like if and then rule concept, if you are using if and then rules we are using, that time if and then that's fuzzy logic. That is a comes under the AI. Then chess playing of the game, TikTok games, all are we are using logical moves only. So that is called AI. Okay. So machine learning, where machine learning we can use. Suppose I am going to predict, I am going to classify that. Okay. For example, student performance prediction, credit card fault detection, spam mail prediction, spam mail detection, house price prediction. Okay. Prediction about a PV panel power. Okay. Prediction of PV panel power. Then identification of the faults in the induction motors. So all are comes under the machine learning concept. Okay. Then what is a deep learning? So deep learning mostly, from my knowledge, we can use mostly they are using classic regression type of problems, prediction things. Okay, handwritten digit recognition, face recognition system, speech to text, speech to text, then image classification. Suppose you have millions of data sets are there. So these kind of application, whenever the complexity increases in your things, the deep learning is presented. Images, image pixels or video or audio signals. Okay, then you are having the data set about millions of data sets are there. So these kind of things are there. Automatically, you go for a deep learning. So mostly it is used for that for a regression kind of problem, not a classifiers. Okay, and also images data sets we can prefer the CNN. CNN is convolution neural networks model. So this is a comparison. Okay. So rules and the if and logic now you can use AI model. Structured label data sets are presented now use ML or minimum amount of data sets. Suppose in my data set I have voltage, current, power, fault. Only 4 data are there means better I go for a ML. Okay. Then images, audio, text level for a complexity of the data are present, you go for DL. Sometimes some of the problem statement it is a common. We can use both AI ML also or ML DL also. Okay, that is an mixed one. Okay, for small data sets we can go for a AI and ML. Large data sets we can go ML and DL. Both are also a good option. Okay, so only I'm restricting here. So some based on the problem statement we can go. Okay, but while going to the deep learning, lot of constraints are there. Okay, but you can get the answer in the more accuracy than the machine learning. Okay, then high accuracy you can go for a deep learning. Then comparison about your problem statement is logical oriented in the sense go for AI, but normally in our electrical side we are not going more about the logical based only data driven approach is present. So you have a data more amount of data so then go for ML or DL. Then handle audio and video no better go for deep learning. Okay, but machine learning also possible, but you have a large amount of data sets in the sense the space is very high. For example, if I show one code, if I run the code means it will take around 15 minutes or record will run the deep learning because space is very high. Okay, then complexity is also very high in the deep learning. Machine learning only data set, data pre-processing, algorithm selection, predicting the output. Only these 4 steps are there. But deep learning is not there. Okay, in deep learning also we have one important thing is that is called hyperparameter tuning. Okay, that is a hyperparameter tuning. So hyperparameter tuning now we can optimize the select the input parameter. That is the biggest work. Okay, so here we can simply use the algorithms, but deep learning is somewhat different. So algorithm selection about ML, supervised learning already we explained, unsupervised also we have already explained to you. Based on the problem statement, you can use the algorithm. Deep learning now. So the important algorithm presently mainly we are focused on CNN. If image classification under CNN, almost 10 types are there, 10 or 12 types are there. Okay, mobile net, then Alex net, this all are comes under the CNN. Okay, recurrent neural network also very important algorithm. Suppose you have a sequence amount of data are there in your system, you go for a sequential data. Now you can go for a RNN. Suppose in your data sets time series are presented in the sense go for LSTM. So LSTM means long short-term memory algorithm. You can use suppose your data set should have a time-based system. So for example, in 8 o'clock, what are the data sets are there? Suppose 8.01, what is the data set? Time-based series is presented in the sense you can go for a LSTM. Okay, next one is GRU. GRU means this is also efficient sequence modeling. Okay, actually RNN type is LSTM and GRU. RNN type is LSTM and GRU. So type, not a type, it is an next version. You can tell it is a next version. So while using the algorithm, your LSTM should be more efficient than the RNN. That is also we need to consider. Okay. For example, I have one problem statement in that EV data set. I have run the system. Suppose RNN accuracy will be 0.3. Suppose LSTM accuracy is 0.7 in the sense I am running the system in a wrong way. So once again you have to fine tune the model. Fine tune the model in the sense select the batch size. Okay, select the batch size, select the tuning parameter, select the neurons, select the approaches. There are a lot of things are there in the deep learning. Okay, so first, well, if you want to do the project in the deep learning, first step is hyperparameter tuning. You have to be in confidently. Hyperparameter tuning. Then optimization model is there. Okay, then major problem we are facing deep learning is overfitting. Okay, so in order to reduce the overfitting model, regularization methodology is something we have used. That also you have to consider. Okay, so all the three, for example, what I think I'm telling that regularization, optimization, okay, regularization, optimization, hyperparameter tuning. You have to strong in all these three, then you can use that algorithm, so it will be very efficient. Okay, so for one algorithm I'll explain based on the time constraint. I'll explain one algorithm, and I have one data sets are there. One is a convolution neural network. So convolution neural networks now, if only the images data set you have to put. Okay, but some of them they are using that value also. They can use that CNN, but it is wrong. Okay, so in my knowledge it is wrong because the convolution neural network layer is working with is lot of backgroundly calculating the pixel levels. Okay, it will go some levels, right? Even if you are running the code, it will be works. But the problem here is not accuracy manner. Here, just I explained, then you know that why image data is required in the convolution method. So we should be avoid that normal data set while using the convolution. If you have an image data sets are there, means better go for a convolution. So we know it is a bad, but how deep learning it will be learned now. There are some steps are there. Okay. So first step is this is a neural network structure. Okay, so first structure is convolution layer. Okay, so input layer, output layer, hidden layers are there. The hidden layers are there. The all input layers. First, we have a number. Okay, we have some numbers are there. It will calculate as a number. For example, if number 8 is presented now, in that 8 where the 8 is covered in the cell 8 cross 8 cell, the 8 covered is presented as 1. Okay, so for example, this one is covered, right? So all this one represents the covering point of the 8. Okay, so this is a way where your bird is covering. We have to give a number. Okay, that matrix is required. Okay, then do the convolution layer. So convolution is it can be converted into that your feature extraction. Mainly convolution is used for a feature extraction. The next layer is there, that is called activation layer. Okay, so this is the example about the feature extraction. Next, you have to go for activation layer. Mostly activation layer, normal machine learning, normal AI we can use for a sigmoidal function. But here we can use the ReLU layer. ReLU rectified linear unit layer. That is nothing but less than 0 it will be 0. More than 0 it will linearly it will be increases. So mostly this layer will be used. So after extraction, we have one number will be there. We can apply the filter. Okay, we can apply the filters logic. Filters now, what is the unit of the filter? Suppose we know it is a bird. So filter is nothing but used to find that edges. Okay, what is the edges of this bird? Everything it will be calculated. Okay, so that is called filter. After filters, we have an answer. You can use the maximum pooling layer. Maximum pooling layer, we have 6847. From that, we can finally I need a single dimensional waveform, so you can use the flattening. Okay, so for identification of this bird, there are background a lot of works are happening. Okay, so another two algorithm is LSTM and GRU. Okay, first I'll explain how to run the code in the for image data sets in the Google Color platform. The remaining algorithm you can study later. Just 2 minutes, I'll run it, then we'll discuss. Okay, just I run one deep learning code. Here, so we'll run the deep learning now. First, you have to import TensorFlow. TensorFlow is an like how we are using machine learning NumPy. Here, the same thing is TensorFlow. You have to use a TensorFlow for a standard neural network model. That is a TF. Okay. Then Keras. Keras is a API model. Okay, it's a physical interface. So, for example, you consider as a bank. Okay, in the bank, ATM is that is a Keras. Bank is TensorFlow. Okay, same way you can understand that. Then data set layers and models. Then plot MATLAB plot. Okay. So here directly I can upload the over every time I don't want to download. Okay, you consider that data set CIFAR dot load data. CIFR is a Canadian Institute for Advanced Research. That is called CIFR. Actually, this data 10 there are around 60,000 images are there. Okay, 60,000 images, 10 different images application like aeroplane, mobile, bird, cat, dog. 10 different images are there. Okay, but 60,000 images is presented. But I cannot upload that now. Okay, so I directly call. Space is very high, so directly we can upload the data from the cloud platform itself. Okay, then each image is having the what is that height, width channel. Okay, height 32 pixel, 32 pixel, 3 is a channel. Channel means color, like a red, green, blue. Okay, then testing data set, training data set. So total 60,000 images are there. So 50,000 for training, 10,000 for testing. Okay. Then you converted the entire pixel model into 8-bit because we receive 8-bit unsigned number for normal image data set. So we have to convert some number from 0 to 255. Okay. Suppose your image pixel size will be 128. Now 128 divided by 255. The corresponding value it will be 10. Okay. Normally it is a 8-bit unsigned number. So 2 power 8 na 256. So we can be calculate according to your data set values. Okay. So every time the dimension will be reduces. Then model you can call the sequential. Why sequential? Because everything layers are presented. Each and every step layers are presented. So you can go for a sequential model. Then use that ReLU. Then padding. Padding now it will be added 0 for that around the images. Okay, for production purpose. So you can use the padding also. After padding, is the convolution model, rectified linear model, because according to the convolution neural network, 2 times you have to use that convolution layer, 2 times you have to use for a pooling layer. Okay. So once again the code will come, same code is presented. After 2 times convolution layer, you can flatten the layer. Flatten a total data set, total single dimension data set. Okay. After that, we need a final output layers. Final output layers, we can call that a ReLU and output in terms of the segments. Okay. If you type model.summary now, that entire what we have done, entire thing it will come in the image data sets. Then select the optimization model, Adam optimization model, and load the accuracy. Finally, you can train the model. One is on validation data. Validation means during training we can find the error value. That's called validation of the data. Suppose if I run the data in the sense, what will happen? It will take around 15 minutes because we have 60,000 images are there. So it will take around 10 to 15 minutes are there. Finally, you have to upload some sample data set. You can find the training testing accuracy. Already I have found that, but it will take more amount of time for considering all kinds of graph losses. And also you can upload the images and find that actual and the predicted value. Okay. It will take around 10 to 15 minutes time because I have given a 10 iteration. 10 approaches I have given. Okay, so all 50,000 data, it will be calculated. It will take some amount of time. So here actually another 2 algorithms are there. Due to time constraints, I just close the path. Actually, there are a lot of research opportunities are there in this field. Okay, there are every day we have a large amount of data sets we have collected that, but we can know that how the algorithms are useful for a particular application. Okay, so next level of learning also the cyber physical system is presented for handling the data in an encryption way. So there are a lot of research opportunities are there in the particular area. So due to time constraint, I stop now. If you have any doubts, you can ask the question.
Sir, there will be the question in chat box, sir.
Okay. Wait, sir.
Hello, good evening, sir. Good evening.
Yes, sir.
Okay.
Sir, myself Manjunath. Even I am 2014 graduate from Vellore Institute of Technology.
Oh, okay, sir.
Actually, I am doing that research on batteries. Okay,
Okay,
it is
okay.
charging and discharge modules. So, which AI can I use, sir?
So that's I'm telling. So based on your output is necessary, sir. For example, you are going to find the faults in the battery. Now you go for a machine learning. Suppose you want to find the parameter. For example, SOC you are going to predict in the sense that also you can go for a machine learning. But suppose if you have a more large amount of data sets, like a 1 lakh amount of data sets are presented in your problem statement. There are more columns are there. There are more inputs are there is presented in the sense. Better you go for a deep learning.
Okay.
Deep learning, a lot of algorithms are there. You can go based on data sets. Your target value will decide, sir. Your target value will decide whether you are going to find a different faults. Now there is only one option: go to machine learning, or you are going to find a parameter. Now go to machine learning regression algorithm. Suppose you have a large amount of data sets with the different parameters you are fine tuning, and you are going to find that millions of data sets prediction model. Now, with the help of the prediction model, you go for a deep learning. In the deep learning, if you have time series data sets, now you go for a LSTM and other layer model. Suppose image, now you can go for a CNN. You should not
For
use the
thermal
data set.
simulations, for thermal simulations.
You have a data set is there. Thermal also, thermal simulation is an, suppose you have images or Excel format.
It is Excel format.
Excel format, now don't use CNN. Remaining algorithm you can select, sir. RNN is there, GRE is there,
Okay.
then LSTM is there, by LSTM is there. You can use that algorithm.
Okay. Thank you, sir. Thank you.
Thanks. Can you suggest where I can get real-time EV data sets for price and charging demand optimization and controlling the converter for GTVT technology? Actually, this is the same problem we are also facing things. So what is the problem is we in our India, normally we are not managing that customer's record and everything. You can use that data sets, open source data sets are there, like Kaggle is there, Picshare is there. You can use that machine learning repository, the data sets also there. But if you do the research work, in the sense, if you are doing PhD, you are going to for your degree, in the sense, better go industries, EV industries. Okay, then note down the readings for at least 6 months of the data. You have a data sets, then you can using the algorithms. That is the only best case when compared to all. You can go with an industry, do the internship, get the data sets, or better you can install EV charging station, small mini EV charging station in your institution itself, and you can collect the daily data sets. And after getting on 6-month data sets, you can train and testing about the system. If you go the real-time data sets, open source data sets, there are a lot of available. Go to Google website and the Picshare websites are there that you can download the data. So I hope I have told the two questions also same answer. Right, so share my contact details. Please note down that if you have any further interaction or further help in your research works, please contact me.
Thank you, sir. Thank you for your valuable session, sir.
Thank you.
Participant, the feedback link has been posted in chat box. Kindly fill the feedback form for the session 6-7. Thank you, sir. Sendil Kumar, sir.
Okay, sir. Thank you, sir. So once again, I want to thank all the participants, coordinators, HOD, and all faculty members of Tribute Department, PSNA College of Engineering faculty members. Thank you for the given the opportunity. Thank you, sir.
Thank you, Sendil. Thank you.
On behalf of all AICTE ATAL Faculty Development Programming Organization Committee, I extended our sincere thanks to Dr. R. Sendil Kumar for delivering an insightful and thought-provoking session on AI and machine learning application in electric vehicles. The session providing valuable perspective on EV system, battery management, smart charging, and future reasoning direction, which will greatly benefit all participants. We also thank all faculty members and participants for their active involvement and interest throughout the session. With this, we conclude the 7th session. Thank you all and have a wonderful day ahead. The feedback form is posted in the chat box. Kindly give the feedback. And once again, thank you all and stay connected for the 8th session.